Assalamualaikum warahmatullahi wabarakatuh. We are presenting our assignment AC to AC converter. I'm Muhammad Najmuddin bin Muhammad Yusof.
I'm Nur Darusha binti Badrul Hisham.
Okay, for introduction, AC voltage controllers. AC line voltage controllers are employed to vary the RMS value of the alternating voltage applied to a load circuit by introducing transistor between the load and the constant voltage AC source. The RMS value of alternating voltage applied to a load circuit is controlled by controlling the triggering angle of the transistor in the AC voltage controller circuits. AC voltage controller is a type of transistor power converter which is used to convert a fixed frequency AC input supply to obtain a variable voltage AC output. And lastly, the RMS value of the AC output voltage and the AC power flow to the load is controlled by adjusting the trigger angle, such in the diagram below.
Type of AC voltage controller. First, single phase AC controller. Malaysian standard 230 volt RMS, 50 Hz. May subdivide into uni and bidirectional. Two type of wave, half and full AC voltage. Second, three-phase AC controller, Malaysian standard 400 volt RMS, 50 Hz. May subdivide into uni and bidirectional. Two type of wave, half and full AC voltage. Application of AC voltage controller. First, illumination control in AC power circuit, induction heating, transformer tap changing, industrial heating and domestic heating, speed control of induction motor, and last, AC magnet controls. AC voltage control techniques. Phase control technique. First, transistors are used as switches to connect the load circuit to the input AC supply. Second, AC supply voltage is dropped using transistor during a part of each input cycle. Third, transistor switch is turned on for a part of every half cycle. Input supply voltage appear across the load and then turn off during the remaining part of input half cycle to disconnect the AC supply from the load. By controlling the phase angle or the trigger angle, the output RMS voltage across the load can be controlled. Transistor AC voltage controller use AC line communication of AC phase communication. Transistor in AC voltage controllers are line commutated, phase commutated, since the input supply is AC. Next, 8. When the input AC voltage reverses and becomes negative during the negative half cycle, the current flowing through the conducting transistor decrease and fall into zero. 9. Thus, the on transistor naturally turn off when the device current falls to zero. Phase control transistor, which are relatively inexpensive converter rate. 13. Transistors which are slower than test switching inverter grade transistor are normally used. For application up to 400 Hz, if triads are available to meet the voltage and current rating of particular application, they are more commonly used. Due to AC line commutation or natural commutation, there is no need of extra commutation circuit circuitry or component, and the circuit for AC voltage controller are very simple. 16. Due to the nature of the output waveform, the analysis derivation of expression for performance parameters are not simple. Capacity for the phase control AC voltage controller with RL load 17. But however, most of the practical loads are of the RL type, and hence RL load should be considered in the analysis and design of AC voltage controller circuit.
Okay, for the AC voltage control techniques, principle of on-off control technique, integral cycle control. First, the basic principle of on-off control technique is explained with reference to a single phase full wave AC voltage controller circuit shown right side. The transistor switches T1 and T2 are turned on by applying appropriate gate trigger pulses to connect the input AC supply to the load for the n number of input cycle during the time interval T on. Third, the transistor switches T1 and T2 are turned off by blocking the gate trigger pulses for m number of input cycle during the time interval T off. Fourth, the AC controller on time T on usually consists of an integral number of input cycles. Then referring this diagram of the waveform of on-off controlling technique in the side diagram, at the end two input cycles, the transistor are turned on during T on for 2 input cycles, and the M1 input cycle transistor are turned off during T off for 1 input cycle. Next, the transistor are turned on precisely at the 0 voltage crossing of the input supply. The transistor T1 is turned on at the beginning of each positive half cycle by applying the gate trigger pulses to the T1 as shown. During the on time T on, the load current flows in the positive direction, which is downward direction as shown in the circuit diagram when T1 conducts. The transistor T2 is turned on at the beginning of each negative half cycle by applying gating signal to the gate of T2 during T on. Next, the load current flows in the reverse direction, which is the upward direction when T2 conducts. Thus, we obtain a bidirectional load current flow alternating load current flow in a AC voltage controller circuit by triggering the transistor alternately. 7th, this type of control is used in applications which have high mechanical inertia and high thermal time constant, such industrial heating and speed control of AC motors. And lastly, due to 0 voltage and 0 current switching of transistor, the harmonics generated by switching action are reduced. So this is the some calculation that we can conclude. So for the sine wave input supply voltage like that, if the input AC supply is connected to the load for n number of input cycle and disconnect for m number of input cycle, then T on equal to n times t and T off equal to m times t, where t is equal to 1 over frequency is equal input cycle time. So we can show that output RMS value equal to V in RMS then the square root and such, where V RMS is the RMS input supply voltage. So that's all from us. Thank you.